Have you ever wondered why your hair stands up when you rub a balloon against it? Or why lightning strikes during a thunderstorm? Let's take a journey back in time to ancient Greece to answer these electrifying questions. The concept of electric charge has its roots in the observations of ancient Greeks, who discovered static electricity over 2,500 years ago. They noticed that when they rubbed amber, a naturally occurring resin, it would attract lightweight objects like feathers. Unbeknownst to them, they were witnessing the effects of static electricity, a phenomenon that would later lead to the development of the concept of electric charge. Fast forward to the modern age, and our understanding of electric charge has become much more sophisticated. We now know that everything around us, from the chair you're sitting on to the device you're using to watch this video, and yes, even you, are made up of tiny particles called atoms. These atoms are composed of even tinier particles: protons, electrons, and neutrons. Protons, found in the nucleus at the center of an atom, carry a positive charge. Orbiting the nucleus are electrons, which bear a negative charge. Neutrons, also nestled in the nucleus, are neutrally charged, meaning they carry no charge at all. But how does this relate to our daily lives? Well, the interaction of these charged particles is responsible for the electricity that powers your home, the static shock you feel when you touch a metal doorknob, and even the lightning that lights up the sky during a thunderstorm. The concept of electric charge is much more than a scientific theory. It's a fundamental property of matter that underlies many of the phenomena we experience in our daily lives. So the next time your hair stands on end when you rub a balloon against it, you'll know it's all thanks to the electric charge. So, the electric charge is a fundamental property of matter, responsible for electricity-related phenomena we experience in our daily lives. Let's explore this fascinating world of charges further in the next scene. Now, what exactly are these positive and negative charges we just mentioned? Well, allow me to take you on a trip to the atomic level, where everything begins. Picture atoms. They're not just tiny balls of matter, but are composed of even tinier particles, namely protons, neutrons, and electrons. Protons, located in the atom's nucleus, carry a positive charge. On the other hand, electrons, which whirl around the nucleus in a cloud-like formation, possess a negative charge. Neutrons, also in the nucleus, are neutral, carrying no charge at all. Now, when an object has an equal number of protons and electrons, it's considered electrically neutral. That's because the positive and negative charges balance each other out, resulting in a net charge of zero. However, if an object gains or loses electrons, the balance is disrupted. Let's say an object gains electrons. Since electrons carry a negative charge, the object becomes negatively charged. Conversely, if an object loses electrons, it ends up with more protons, making it positively charged. But why does this matter? Well, these charges aren't just static. They interact, and these interactions play a significant role in our daily lives. For instance, when you rub a balloon against your hair and it sticks to the wall, it's due to the transfer and interaction of these charges. You see, when two objects come into contact, electrons can transfer from one object to the other. This can leave one object with an excess of electrons and the other with a deficit. The object with the excess becomes negatively charged, and the one with the deficit becomes positively charged. Remember, similar charges repel while opposite charges attract. This basic rule governs the behavior of electric charges. So the positively charged object and the negatively charged object attract each other, like two pieces of a puzzle coming together. This is the essence of electrostatic force, a fundamental part of our universe, and we'll delve deeper into this in our next scene. What happens when charges interact with each other? Let's explore. When we talk about interactions between charges, we're stepping into the fascinating world of electrostatics. It's a realm where invisible forces make things move without touching them. Pretty cool, right? So let's dive in. There are two fundamental principles that govern the interactions of electrical charges. The first is that like charges repel each other. This means that two positive charges or two negative charges will push each other away. Imagine you and your sibling both wanting the last piece of cake. You're both going to push and shove to get it, right? That's exactly how like charges behave. The second principle is that unlike charges attract each other. A positive charge and a negative charge will be drawn towards each other. Think of it like this. You've been eating healthy all week, and then you see a slice of delicious pizza. You're drawn to it, aren't you? That's how unlike charges feel about each other. To illustrate these interactions, let's bring in a couple of charged balloons. If we charge two balloons negatively and bring them close, they repel each other and try to move away. But if one balloon is positively charged and the other negatively, they'll be attracted to each other and try to come together. Similarly, we can see this with pith balls. Pith balls are small, lightweight objects that are often used in physics demonstrations. If we charge two pith balls positively, they'll repel each other. But if one is positively charged and the other negatively, they'll be attracted to each other. Through these examples, we can see how charges interact with each other. And it's not just interesting science trivia. These principles are at work all around us. They're the reason why your hair stands up when you pull a woolen cap off your head in winter, or why clothes stick together when they come out of the dryer. So the way charges interact forms the basis of many natural phenomena and technologies we see around us. Ever wondered why we use the term grounding or earthing in electricity? Let's find out. Our planet Earth is not just a celestial body floating in space. In terms of electricity, it acts as a vast reservoir of neutral charge, ready to absorb excess positive or negative charges to maintain balance. This process, my friends, is what we commonly refer to as earthing or grounding. Now you might ask, why is earthing so important? Well, imagine you're living in a house filled with electrical appliances. Each appliance, from your refrigerator to your mobile charger, carries an electric charge. Without proper grounding, any malfunction or short circuit could cause these charges to build up, leading to potential electric shocks or even fires. A scary thought, isn't it? But here's where earthing comes to the rescue. It provides a safe pathway for these excess charges to flow directly into the ground. This means even if there is a fault in your electrical system, the chances of receiving a shock are significantly reduced. It's like having a superhero in your home, constantly shielding you from potential electrical dangers. Consider the 3-pin plug that we commonly use. The third pin, often longer than the other two, is the grounding pin. It connects the appliance directly to the earth, ensuring that any excess charge is safely dissipated. It's a simple yet ingenious design that has undoubtedly saved countless lives. Earthing is not just limited to our homes. It's a critical safety measure in workplaces, hospitals, and practically anywhere with an electrical system. It's also a fundamental principle in designing electrical circuits, ensuring they operate safely and efficiently. So the next time you plug in your laptop or switch on your television, remember the silent guardian that is earthing, quietly working in the background to keep you safe. In essence, earthing serves as an excellent example of how understanding and applying basic scientific principles can significantly enhance our everyday lives. So, earthing is a crucial safety measure in any electrical system, protecting us from potential dangers. How does understanding electric charges help us stay safe during a thunderstorm? Let's delve into the science of lightning. Lightning is, in essence, a large-scale natural demonstration of charge transfer. It's Mother Nature's extravagant show of power, but it's also an excellent example of how electric charges interact. When a thunderstorm brews, a fascinating process begins in the heart of the storm clouds. As the storm intensifies, charges within the cloud start to separate. This is due to the turbulent movements within the cloud, causing smaller, lighter particles to move towards the top, gaining a positive charge. Meanwhile, heavier particles sink to the bottom of the cloud, acquiring a negative charge. This separation creates a massive electric field within the cloud. As this electric field grows stronger, it starts to influence the charges on the ground below. It repels the negative charges into the ground, inducing a strong positive charge on the surface and objects on it. When the electric field becomes strong enough, a spectacular phenomenon occurs: a bolt of lightning. This brilliant flash is a massive discharge of electricity, a path of least resistance created between the negatively charged cloud and the positively charged ground. But despite its breathtaking beauty, lightning can be dangerous, even deadly. So how do we stay safe during a thunderstorm? One of the most effective measures is the use of lightning rods. A lightning rod is a metal pole mounted on a structure connected to the ground through a wire. When lightning strikes, it will preferentially hit the rod, as it provides an easy path for the charge to reach the ground, rather than the building. It's crucial to stay indoors during a thunderstorm and avoid touching any electrical equipment. If you're outside, avoid open fields, tall trees, or water bodies, as these can attract lightning. Remember, understanding the science behind these natural phenomena can help us navigate them safely. So, the science of electric charges not only explains natural phenomena like lightning, but also equips us with knowledge to stay safe during such events.